All right, guys. So how this retake review is going to work is I'm going to work out the left side, and your job is to work out the right side. Or for some of them, there can't be a left and right. So I'm going to work out the odds, and your job is to work out the evens. And then once you do that, you can schedule to retake the test. So an equation where f of x is shifted left 7 units and up 3 units. So remember, left and right is inside our parenthesis. So this will be f, and it's opposite on the inside. So x plus 7. Up 3 would be it on the outside, so a plus 3 on the outside. Number 3, remember, inside moves our graph left and right. Outside moves our graph up and down. So the minus 4 on the inside, it's opposite on the inside, is going to move our graph right 4. And the plus 1 on the outside is going to, or excuse me, the minus 1 on the outside is going to move our graph down 1. All right, 5. We're given f of x on the left-hand side, and we want to write a transformation for g of x. So basically, I'm going to find one point and kind of focus on that. So I'm going to look at this point here. And you can pick any of the points, doesn't matter. So this graph has gone right from f to g, 1, 2, 3, 4. And it has gone up. Actually, let me redo this. It's gone right 2, because this scales by 2. And it has gone up 1. So this means that g of x is f of x minus 2 plus 1. All right, you guys are going to do number 6. All right, so for 7, 8, 9, and 13, I'm going to be referring to this graph. So on the interval, -6 to -2. So that means from where x is -6 to where x is -2. So on this interval, so this portion of my graph, describe the function. So from these 2 points, my function here is increasing because it's going up from left to right. The big thing is that it's an interval, it's not a point. So if we tried to find the point -6, -2, that point is not on my graph, but it says interval. So we're looking from where x is -6 to where x is -2. All right. Number 9, we're looking at the interval -4 to 0. So let's go back to our graph. We're going to be looking from where x is -4 to where x is 0. So from where x is -4 to where x is 0. So that would be this portion. So to describe this graph, or this section is all above the x-axis, which means f of x is positive. Okay. 11, describe what's happening at the point -1, 1. So this is where x is 1 and y is -1. So where x is 1 and y is -1 is this point right here. So this point is lower than all the points around it, so it is a relative minimum. "13, describe the function at the point 2, 0. So this is where x is 2 and y is 0. So where x is 2 and y is 0, that would be right here. So at this point, this graph has a x-intercept. All right, so for the next handful of problems, I am using this graph for the odds 15, 17, 19, 21, and 23. And we're going to write all answers in interval notation. So what is the range of g of x? So remember, your range is your lowest point to your highest value. So if I look at this graph, my lowest, and this is all range is also y's. So my lowest value on this graph is at y is -3. Since it's actually touching -3, we'll put a bracket on -3. And then my graph is going up. So my highest point would be positive infinity. Now for my domain of g of x, your domain is your x values. And it is your furthest left to your right. So my furthest left x value, I have an arrow that's going to the left. So I'm going to keep going to the left forever. That means my furthest left value is -infinity. For the right, I have an arrow going to the right. So that means my furthest right value would be positive infinity. Over what intervals is g of x decreasing? Decreasing means it's going down from left to right. It's got like a negative slope. So as I look at my graph, this section, I didn't trace that very well, is the part that's going down. So when we write the intervals, we write the furthest x that it's going. Well, I've got an arrow to the left, so that would be -infinity, to where the x of this point, where x is -1. So this is on the interval -infinity to -1. Where is g of x negative? So this negative means it's below the x-axis. So for below the x-axis, I'll go back to my graph. This is where it starts going below, and this is where it ends below. So remember, when we list off interval form, we list off the x values. So the x value where it starts to be negative to the x value where it ends being negative. So this is from -4 to -2. This is the interval -4 to -2. What is the value of the y-intercept? That's where it crosses the y-axis. So where it's crossing the y-axis is at this point here. And this is the point -2. All right, solve the systems of equation below. So we can solve this algebraically by setting them equal to each other and solving, or I think this problem is easier to solve for graph based on graphing. So I'm going to show the graphing method. If you'd like to know how to do it without graphing, then substitution, we can do that as well. But remember, your solution is the point where they intersect, which makes it true for both equations. So it should work for both equations. So let's focus on the -2 absolute value of x plus 3 plus 4. This is a V-shaped graph that has gone left 3 and up 4. So I go left 3 and up 4, and I make my vertex point. Now, my -2 means that the slope of each of my lines is going to be -2. So I'm going to go down 2 and over 1 in both directions. So down 2 over 1. And then it's a V, so these are straight lines. Down 2 over 1. And we just continue this pattern. Now my next equation, the y equals x plus 4, this is just a line with a y-intercept of 4 and a slope of 1. So I go to a y-intercept of 4 and a slope of 1. So I go up 1 over 1, up 1 over 1. And I can also go the other way. And we can see from here where our graph intersects. So the coordinate points where they intersect is the point -2, 2. And the point -6, -2. Now remember, this should be true for both equations. So if I plug in these points into both of my equations, it should work. So if I plug in -2 in my first equation, -2 plus 3 is 1, times -2 is -2, plus 4 is 2, which is what I should get out. -2 plus 4 is 2. And I should get the same thing if I plug in -6, I should get out -2. So -6 plus 3 is 3. Excuse me, -3. Absolute value of -3 is +3, times -2 is -6, plus 4 is -2, which is what we should get. And then -6 plus 4 is also -2. All right, graphing the piecewise function. So what I like to do is graph the whole line and then erase the parts that I need. So 2x minus 1 This is a line that starts at -1 and has a slope of 2. So I'm going up 2, right 1, up 2, right 1, up 2, right 1. I can also go the other way. Now, I only need this line from where x is less than -2. So on my line where x is -2, I'm going to make an open circle. So where x is -2, I'm going to put an open circle. And I only need it to the left, so I only need it less than this line. So I'm basically just going to erase the parts I don't, too much. I'm going to erase the parts I don't need. Right? And I'll do the same thing with my next line. So -x plus 5 means I'm going to start at 5. And I have a slope of -1. So I'm going to go down 1, right 1, down 1, right 1. I can also go the other way. And then I'll draw my line. Now let's look at our interval. I only need this graph where x is greater than -2. So I'm going to make a closed circle on my line where x is -2. And greater than means I only need it to the right. So I only need this part. So I'm going to erase the piece that I don't need. All right, so now what we're going to do is write an equation. So we have 3 pieces. So we'll have 3 parts. So let's look at our first part. I've got this line right here. This is just a horizontal line at 6. Now the x value of my endpoint is at -4. It's an open circle, so it'll just be a less than -4. My next piece, let's look at this middle piece here. So this is a line that has a y-intercept of 1. So most lines we're going to put in our y equals mx plus b form. So the y-intercept of b is at 1. And the slope, I'm going up 1, right 1, up 1, right 1. So this would be a 1x plus 1. And I am graphing this line between where x is -4. It's a closed circle, so less than or equal to x, which is less than or equal to where my point ends. So 1, 2, 3, +4. And now let's look at our last piece. So here it's a line. To be able to get my y-intercept, I'm going to just kind of extend this line to where it would cross. So if I extend this line, this is a y-intercept of +2. The slope of this line is -1. I'm going down 1, right 1, down 1, right 1. So this would be a -1x plus 2. Because the slope is -1 and the y-intercept, if I extended it, would be 2. And I'm only graphing this line from where x is at 4 and to the right of 4. So x is greater than or equal to 4. All right, in June you start a holiday savings account and you deposit $30. Then you deposit $44 until the end of the year. So your recursive definition that we want to write is a sub n, and our formula is a sub 1, where n equals 1, and then a sub n minus 1 plus our common difference, wherever n is greater than 1. And for our recursive formula, all we need to do is replace our first term and then our common difference. So our first term is going to be 30. Our common difference is going to be 44 because we're adding 44 each time. So we're adding 44 to our previous term. So this should be a sub n equals 30 when n equals 1, because there'll be $30 in there the first month. And then we take the previous month and add 44 whenever n is greater than 1. So if we're looking for the fourth month, we take however much we had in the third month and add 44. So how much will we have saved by the end of December? Well, if we started in June, the end of December would be where n is 7. So what we could do is we could just add 44 6 times, or we could just list off our numbers. So in the first month, when n equals 1, we'll have $30. When n equals 2, I'm going to add 44 to that. So I should have $74. And then we just continue this pattern. So when n equals 3, n equals 4, n equals 5, n equals 6, going a little bit to the next one, n equals 7. So I'll have 118, 162, 206, 250. And in the 7th month, we should have $294 in there. All right, on October 1st, Nadia starts a push-up challenge by doing 18 push-ups. October 2nd, she does 21 push-ups. October 3rd, she does 24 push-ups. She continues this pattern through October. Write an explicit definition. So our explicit definition form is a sub n equals a sub 1 plus our difference times n minus 1. And just like our recursive formula, we have to replace our first term and our common difference. So our first term, she starts with 18 push-ups. And our common difference, each day, it looks like she's increasing it by 3. So our common difference would be 3. So a sub n equals 18 plus 3 times n minus 1. Now, if your common difference is you're going down, you're decreasing, your common difference would just be negative. All right. What is the solution to x squared plus 2x minus 15? So I'm going to factor this. I'm going to look for factors of negative 15 that have a sum of 2. So two numbers that multiply to negative 15 and add to 2. So those two numbers should be positive 5 and negative 3. So we have x plus 5 and x minus 3. So what I'm going to do is I'm going to find where each of these equals 0. So x plus 5 equals 0, and x minus 3 equals 0. So we get x equals negative 5 and x equals 3. So we can do this with a number line, or we can do it with a graph. Either way. So if we think about it graphically, -5 and +3 are my y-intercepts. Excuse me, my x-intercepts. And x squared, this makes a parabola. So if I want to find where this graph is greater than 0, that's above the x-axis, so that is this piece and this piece. So we could write it in interval notation, or we can just write it in set builder. So the left piece is where x is less than -5. The right piece is where x is greater than +3. We also did this via number line on the in the notes and on the homework as well, but we can do it as a graph. Solve and graph the absolute value inequality. So first thing we want to do is get the absolute value by itself. So I'm going to subtract 1 from each side. So the absolute value of 2x minus 3 is greater than or equal to 3. And then we'll split this. So we'll have the absolute value. Oh, when we split it, we don't need to write the absolute value anymore. So I'll have 2x minus 3 is greater than or equal to 3. Greater than or equal to is an or. So or, and then we flip the right side. So we flip the sign and make the 3 negative. So 2x minus 3 is less than or equal to 3. -3. And then we'll solve each one. So I add 3. So 2x is greater than or equal to 6, which means x is greater than or equal to 3. Or, on the right side, when I add 3, I get 2x is less than or equal to 0. So x is less than or equal to 0. So this is going to be a closed, the first one is a closed circle on 3. Greater than 3 would be to the right of 3. X is less than or equal to 0 would be a closed circle on 0 to the left of 0. So there's my graph. Solve this algebraically. You can use substitution or elimination. I'm going to use elimination. So I'm going to try and eliminate the x's first. So I'm going to try and make the x's both 15. So to do that, I need to multiply the first equation by 5 and the second equation by 3. I also need one of them to be a negative. So right now they'd both be a positive 15. So I'm going to make the top equation a -5. So when I multiply everything in the top equation by -5, I get -15x plus 10y equals -10. Everything in the bottom equation by 3 gives me 15x minus 15y equals 30. And then I'll add the two equations together. So -5y equals 20, which means y equals -4. I'd then plug in -4 into either of my equations. So I can plug it into the first one. So 3x minus 2 times -4 equals 2. 3x plus 8 equals 2. 3x equals -6. So x equals -2. So the coordinate point where these two lines intersect is the point -2, -4. All right, so let's graph 41. So x is greater than or equal to -4. This is a vertical line at -4. It is solid because of the or equal to point line underneath it. So I go to x is -4, and I'll draw a solid vertical line. Greater than -4 means I'm lightly shading to the right of -4. My next equation, y is less than or equal to -2x plus 4. The y-intercept is 4 with a slope of -2. So I go to 4 on my axis, and I have a slope of -2. So down 2, right 1. And this will be a solid line because the or equal to line underneath it. Less than means I'm shading below this line. So I'm shading over here. Then my last equation, this x minus y is less than 7. I need to solve for y first before I can graph this. So first thing I'm going to do is subtract x from each side. So I get -y is less than -x plus 7. And then I'll divide everything by -1. So y, when we divide by a negative, it flips the sign. So y is greater than a positive x minus 7. So I go to where on my y-axis, -7. And I have a slope of +1. And I can also go the other way. This is going to be a dashed line. Where we shade up because it's greater than. So I'm shade up. Shade over here. Now the area where all three of my shading overlaps is my answer. So I should have my answer is this area here because it's the area that has all three shading. We just kind of make it darker. All right, last one. Write the inequalities that represent the constraints for the situation below. A carpenter makes 2 bookcases in two sizes, large and small. It takes 4 hours to make a large bookcase and 2 hours to make a small one. The carpenter can only spend 32 hours each week in making bookshelves, and he must make at least 2 large and 4 small. So I'm going to let X be my large bookcases. And I'll let Y be the small bookcases. So my first equation, it takes him 4 hours to make a large, 2 hours to make a small, and he can spend only 32 hours making these. So this would be 4x plus 2y is less than or equal to 32. Now he must also make at least 2 of the large. So x has to be greater than or equal to 2, because he needs to make at least 2 of them. And he needs to make at least 4 small each week. So small is y, so y needs to be greater than or equal to 4. And that's my equations.